Welcome back to the video, and today we're going to be creating our own linked list data structure in Java. So in order to do that, we're going to have three classes. I'm in the main class right now with the main method, and if we run that, it's going to print hello world. So the main method is working as intended. We're going to have a class called list node, which we're going to be using to create nodes, and then we're going to be adding them and linking them in the linked list class. So first, let's work on the list node class. So we want this linked list to hold integers, so we could say int data, and then we're going to have a pointer of type list node. We'll call it next. So data just holds a number, and then next is going to point to the next node in the list. And then we could have a constructor. We could say public, and then the name of the actual class, which would be list node. And then when a user creates a list node, we want them to pass in a number, and that number is going to be stored inside data. And then that number is going to be stored inside this data variable. So we can say this.data equal to data. That sets this number, what the user passes in, equal to this variable up here. So that's it for the list node class. Now we can go to the linked list class. So we're going to create a node of type list node. We'll call that head. And then we'll create an integer called size, and we'll set that equal to 0. Size will just keep track of how many nodes there are in our list. And then we could say public. Let's get it to be linked list. It's a constructor for our linked list. And that's going to set head equal to null. Because if the list is empty, head is just null. Okay. So that's pretty good and all, but we need a way to actually add nodes to our list. We can say public void add. Okay. So we're actually going to have two add methods. The first one is just going to add either to the beginning of the list or to the end of the list. So we could say int num. So the user is going to pass in a number, and it's going to either add it to the beginning if the list is empty, or to the very end of the list if it's not empty. So we'll have another one. It says duplicate method, but I think it's called method overloading, where we can have same method name, just as long as it has different parameters. There's going to be one called index, and that's going to take like the number wherever they want to add it to the list, and it'll add that num to the list. So if we go to Java, to the main.java class, we can make an object of the linked list. We could say linked list, call it list equals new linked list. And then we could say list dot add. You see how there's both methods? There's one with an index, so we could tell it where to add it, and there's one that doesn't have an index. That just adds it where there's like a location like available for it. And then we'll add one. So let's actually code up these add methods. So first, we need a new node. We need a new node of type list node, and we'll call it new node. Set that equal to new list node. So from the main method, a user could pass in a number. That number is going to be stored inside num, and that num is going to be sent over to list node. In this case, it's 1. One's going to be stored as data, and then data is going to be stored into this data variable, which would just be 1. So there's that. And there's some conditions we're going to have to check. We could say if head equals null. If that's the case, if head is null, it's like the list is empty. So we could say head equal new node. So head is going to point to our new node, and then we can increment size plus plus. We could say size plus plus just adds 1 to the size because there's we just added a new node. And that's the case if the list is empty. But if it's not empty, we could say list node current. We're just making a new list node called current, and we're going to set it equal to head. The reason we're making a current list node is we're going to use this current list node to like traverse the linked list. And then the way we could traverse the linked list, we could use a while loop. We could say while current dot next not equal to null. If it's not null, we're going to keep going in a while loop. And the way we could keep going, we could say current equal to itself dot next. Okay. So this is going to get us to where we want to be at. We want to get to the end of our linked list. Once we get to the end of our linked list, we want to add our new node at the end. We can say current.next equals to a new node. This is extremely confusing if you've never done this, so I'll do a little example to kind of show it. So let's go to our main method. And then we'll have our linked list will have 5 values, 1 through 5. Okay, and we'll use that to kind of explain this. So we'll have a sample list. Okay, so here's our sample list. It's saying, well, current.next not equal null. We know current and head are both pointing to 1. So while current.next not equal null, we're going to keep going and keep advancing through the list. So 1 is current, current.next is 2. 2 is not null, so we're going to keep advancing. So 2 is now current, current.next is 3. So that's not null, keep advancing. 3 is current, current.next is 4, not null. Same thing, 4, 4.next is 5, not null. So now 5 is current. You see how there's no numbers after 5. So current dot, once we advance it, when we say current equals current dot next, so current dot next, no wait, so current is now 5. We're saying, well, current dot next is not null. Current dot next is null because there's no number after 5. So we break out of this while loop. So that just gets us to the end of the list. And then 5 is still current. But now we could say current dot next, instead of it pointing to null, we could have it point to our new node. And that pretty much adds the new node to our linked list. That links 5, and 5 points now to the new node. Hopefully that makes some sort of sense. Just think about it. This gets us to where we want to be. Current.next just points to our new node, which adds it to the list. Since we're adding it to the list, we're just incrementing size. So now size, it takes like a count that we added the new node. So that's if they just want to add to either like the beginning or the end. Pretty much just adds wherever there's a space available. But if they want to add to like the middle of the list to the beginning of the list, they have to pass in an index. So first of all, we're going to have to create a new node. We're going to be adding this new node to the list. Literally just copy and paste it because it's literally the exact same thing. Okay. And like before, there's going to be some checking we have to do. If index is less than 0, most like data structures, they start at 0 for like the indexing. So if index is less than 0, that's a problem. So we could say sysout. This is pretty much like an error message to the user. We could say index cannot be less than 0. And then we'll just do return to get out of there. Okay, that's if index is less than 0. But what if the user wants to add to like the beginning of the list? Say they want to add a number right here. Say this is the first index. Say they want to add a number there. So we can have to take an account for that. We can say if index equals 0. That means if they want to add to the beginning of the list, we could say new node dot next equals to head. I'll explain that right now as well. And then we could set head equal to new node. And we increment size that we do because we're adding to the list. And then we could return just to get out of it. Okay, so let's pull up our example. Okay, say they want to add to the beginning of the list, which would be right here. We want to insert our new node right here to the beginning. Our new node.next is going to be equal to head. We know that head is 1. H stands for head, so head is 1. So new node.next is going to point to the current head. Head is 1, so new node points to 1. But then we want to change the head so the head points to the new node, which is the new head, since we're adding to the beginning. So that's all that does. Head points to new node, which makes new node the head. In the previous line of code, we said the new node.next points to the previous head, which was 1. So that pretty much just adds the new node to the beginning of the list. So there's that. But what if they want to add to like in the middle of the list? We could say list node. Instead of typing it, I'm just going to copy it. We're going to make another current node just so we could iterate throughout the linked list. But instead of using a while loop, we're going to use a for loop. Say for int I equal to 0, I less than index, because we want to like get right before the place we want to add it to. The way we do that is we do index minus 1. That puts us right before the actual location we want to add it to in the list. And then we're also just gonna check that current doesn't equal null, because whenever we deal with nulls, if a node is null, it causes a lot of issues. So we're just gonna check that it's not null. Okay, so that puts us right before the node we want to add it to, which is correct. And then we're just gonna keep going through the list just by setting current equals to itself dot next. Okay, so this puts us right before the node we want to add, which is the place we want to be. But before we do that, we just want to check that current. If current equals null, we just want to print like almost like an error message to the user. We could do sys out. We'll just say invalid index, just to warn the user that hey, this isn't correct because it's null. And then we can just return. Okay, so this puts us right before the node we want to add, which is correct. And then we could say new node dot next. We can set that equal to current dot next. And then once again, I'll pull out my little list so we can actually visualize it, because if not, it's really hard to visualize when you're just learning. Because for me, it was extremely hard. So we could say current.next equal to new node, and then we could increment size. I'm missing a semicolon, but there it is. Pull out the list. Okay. Say we want to add say we want to add our new node at index 1. So index 1 is right here. So we're adding our new node right here. Okay. So new node.next is going to be equal to current.next. So current is going to be equal to head, and head points to 1, so current points to 1. So we'll say c.n just stands for c.next. Okay. So current is 1, current.next is 2. So we want new node.next to point to where, like, the space after we want to add it to. So new node.next points to 2 now, because we want to add it between 1 and 2. And then current.next is going to point to new node, because current is 1, and then current.next, we want it to point to new node. So it kind of like squeezes in again. So 1 points to new node, and then new node points to what was current.next, which was 2. If that makes sense. Let me see if I can kind of explain a little better. Current is 1, current.next is 2. So we want our new node to squeeze in right here between 1 and 2. This gets us there, this while loop. Remember, index minus 1, it gets us to the location we want to be at. Node.next, new node.next is going to point to current.next, which current.next is 2. So now this is in between the 2. But we need 1 to point to new node, so it actually squeezes in between those 2 nodes. The way we do that, we could say current.next is going to be equal to new node, because current.next was 2, but we want current.next to point to the new node. So that pretty much puts it in between the 1 and the 2. Hopefully I didn't confuse you more than before, but that's pretty much it. Those are the 2 add methods we have. So those should work. But in order for us to test them, we have to have a print method. So we could do public void print. The reason it's void, because it's not returning anything. It's only doing something. Then we could copy this line of code right here, just setting current equal to head, so it points to the first node. And then we could say while current not equal to null, while it's not null, we're just going to keep going through the list. But whenever we go through the list, we want to print something. So we could say sys out, but we don't want to do print new line, because that makes a new line for each number. We could say current.val or .data, I think I called it. And then we'll put in a space between them. And then we could set current equal to itself .next. That just keeps current going along like the linked list, if that makes sense. And now if we go to main, we could say list.print. We don't have to do anything because it's already printing for us. because we're already calling the print statement in the list right here. So let me see if I can explain it again. Bring up my list. So up here, what we were doing, let me pull this down a little bit. We were checking while current.next not equal to null. But if we do that, it's not going to print everything. We want to see while current not equal to null. We know current points to what head points to. So 1 is current right now, 1 is not null, print it. Current.data just prints to 1, and then current equals current.next just advances it. 2 is not null, print it. 3 is not null, print it. 4 is not null, print it. 5 is not null, we print it. So once we go from 5, we go current equals current.next. That gives us null. So that just ends the list, ends the while loop. So that prints pretty much the whole list. Okay. So those are the add methods. They seem to be working. Let's go to our main method. Let's do list.add. We'll add an index 0. Index 0, which is the beginning of the list, and we'll add 6 to the beginning of the list. There's no 6 in here, and the beginning of the list is 1. But since we coded that in, it will add 6 to the beginning of the list. This is 0, 1, 2, 3, 4. Let's add 6 at index 4. And it did 0, 1, 2, 0, 1, no, 0, 1, 2, 3, 4, which is the 6 is in there. So that's working as intended. So those add methods work. So that's good, but in order for it to have like an actual working list, we need to have add and then remove methods. So we could define a remove method. We could say public void remove. Just as we did before, we're going to define 2 remove methods. One that just removes like a list from like the back or wherever there's like a node for us to remove from, and then one that removes it where the user wants us to remove it from. We'll get an index, and then we'll remove from there. We'll remove using the index. This method right here just removes where there's a node able to be removed from. So we're going to be doing some checking real quick. We can say if head equals null or head dot next equals null. So in this case, in this scenario, either the list is empty or there's only one element in the list. If that's the case, we could just say head equal to null, because in this case, head is already the list is already empty. So setting it equal to null won't cause anything bad. But if there's one element in there, setting head equal to null just gets rid of that element, which pretty much just removes it. So that's the case if there's only one element. But say there's more elements, we just want to remove from the back. We could say list node current, and then we're going to set that equal to head, and then we're going to have another list node called previous. I think I spelled that wrong. Previous. I can't spell. Previous. You know what? We'll just call it prev, because I can't spell. We'll set that equal to null. Okay. So now we have that. Now we could use the current node to traverse the linked list as we've been doing. We could say, well, current dot next not equal to null. Well, that's the case. We could set prev equal to current, just so we have a way to store current inside of previous. And then we could keep going along our list by setting current equal to itself dot next, just as we've been doing. Oh, I got these confused. I got them backwards. Okay, so this will get us to like the last node we want to remove from. And the way we remove it, we could say prev dot next to set that equal to null. And let's pull out the little example. Start at 1. Current dot next equals null. It doesn't, so we keep going. We assign previous is equal to current, which is 1, and then we keep going throughout the list. Then we go to 2. 2.next is not null because it's 3. Previous is equal to 2. Go to the next element. Go to the next node. 3.next is not null because that's 4. So previous is equal to current, which is 3. And we go to the next one, so current is not 4. 4.next is not null because that's 5. And then previous is equal to current, which is 4. and then we advance to current by 1. 5.next is null because there's nothing after 5. So we break out of this, and now previous holds the number 4, and we're saying .next is going to equal to null. So that pretty much gets rid of 5. So if we go back to our main method and we say list.remove, it should get rid of the number 5, which it does. Okay, so that works as intended, and then we'll remove it now with the index that a user gives us. We'll also have to do some checking. We could say if index greater or equal to size, it can't do that because size is how many nodes we have. It can't be greater than the amount of nodes in the list. Or if index is less than 0, another print statement, we could say just invalid index again, and then we could just return to get out of there. Return 0, or I'll just return. That's if the index is invalid. And then we could check if index is 0, it means we want to remove the head. So if index equals 0, we're removing the head, because that's what the head is. We could set, we're not removing the head, we're just reassigning the head. Head equals to head.next. Let me explain that. 1, 2, 3, 4, 5. Say we want to remove the head, which was 1. So the head is going to point to head.next. Head is going to be reassigned to head.next. So right now 1 is head. And then head.next is going to move the head over to 2. And that's going to be assigned to head. So it's going to be reassigned, pretty much eliminating 1. So there's that. That's if the index is 0. But say we want to remove from like the middle of the list, we could say another else statement, and then just copy and paste. We could say list node current equal to head, just so we can iterate throughout the list. And then we're going to use a for loop to loop through it. For int I equal to 0, I less than, this is the same thing as adding, I less than the index minus 1. We want to be one node before the one we want to remove, and then we could do I++. And then we could set current equal to itself to keep going throughout the list. Current equals to current.next. Okay. So this gets us to like the previous node that we want to be at. So that's correct. And then we could say current.next equals to current.next. So I'll explain that real quick. And then once we're out of there, we'll do size minus. Let me pull out my little list again. 1, 2, 3, 4, 5. Say we want to remove the 4. This for loop will get us to the 3. Because we'll do index minus 1. It goes 0, 1, 2, 3, 4. So they'll pass in the index 4. It will get us to 0, 1, 2, 3. To the third one, which would be the 3. No, wait. 0, 1, 2, 3, 4. They'll pass in the index 3. But we'll do index minus 1, so that will get us to 2. That will get us to the 3. So we're right here. We're at the 3. Right. 3 is current. And we're going to say current.next. Current.next would normally be 4. But we want to say current.next equals to current.next.next. So this is current.next. And the 5 is current.next next. So we're setting current.next, which would normally point to the 4, equal to current.next next, which points to the 5. So that pretty much erases the 4 because it's not the next node, because 5 is not the next node. And that pretty much just gets rid of it, if that makes sense. I'm saying that too much. So we go back to our main method. So it's 0, 1, 2, 3. So we'll pass in 3 as the index. Index 3, and that should remove 4, which it does. So that works as intended. Just trying to do my best to explain it because linked lists are hard when you don't when you can't visualize them. They're pretty hard. And then we could have another method. Pretty much a list is done. We're just adding some methods that are nice to have. This will return the length of our list, and then we're getting an error because it wants us to return a variable type int. We just return size. Then we go to main, we could print the list, and we could do list dot size. This won't print anything because if we run it, it's not going to print anything, but it should just print 4. Because we have to put it in a print statement because we didn't put a print statement where we defined it. So now if we do this, it should print 4. It's going to print on a new line because we print new line and then we print the list. So that's working as intended. What else could we add? Let's do as an empty method. We could say public boolean is empty. Okay. So if this is just going to say if the list is empty. If size equals 0, then yeah, it's empty. We could return true. But if that's not the case, just else. I know there's an easier way of doing this, but this is how I could kind of visualize it better. Also return false. So if we go back to the main method, instead of list.size, we say list dot is empty, false. Get rid of all this. List dot is empty, true. That's working as intended. Kind of have some notes over here. What else should we add to the list? What would be nice? We could do peak, almost like a stack. We could do public void peak. So what the peak method in a stack does, it returns, it doesn't, I guess it returns the first element of the list. So we could check if the head not equal null. If head is not null, we just return head.val or .data. Oh, it can't be void, it has to be an integer. But if not, we could just return -1. -1 is a good way of saying, oh, there's an error. So let's do list.peak. That should just return the head, which it does. Let's put the print statement under where to print the list. That just returns 1. It's adding it to the end of the list because it's not on a new line. So there's that. What other? Oh, let's do a get method. Get methods are pretty cool. We could tell it what index to Oh, that's pretty weird. You could see the reflection of the sun on my green screen. I should wrap this up. It's been a little bit. All right. So let's do public int get. That's how long I've been recording. So we'll ask the user for an index, and then we'll return whatever numbers at that index. So we could say list node current is equal to head, and then let's pretty much copy this code right here. If index is greater or equal to size, or index is whatever, we'll just return -1 because it can't be that. So we'll just pretty much copy that. And then we're gonna use a for loop to iterate through the list. For int I equal to 0, I less than index. We're not gonna go to the previous one because we actually want to return the index we're at. Because we actually want to return the number at that index. And then we could do current equals current itself dot next, just to iterate through it. And then we'll just return current dot next. or current.data. So if we go to the main method, let's get rid of this, just so we can have a new line after it. 0, 1, 2. Let's see list.get, and then we'll pass in the index 2. This is index 0, 1, 2. That should be 3. So it should just print the number 3, and which it does. And then I think that's about it. Oh, let's do one more method. This is a good method to have. Public void. We'll do public boolean contains. Cannot spell. And then we'll pass in a value. Call it int. We'll call it int num. So we're pretty much gonna search through the list and see if the list contains it. We can just use a for loop for int I equal to 0, I less than size, which is just a variable, and then increment I plus plus. And then we could say if get I, this is the method we just created, which is pretty cool. If get I equals val, or in this case we called it num, if that's the case, we just return true, because it means the number's in there. If not, we could just return false by default. Okay, there's that. So we're actually using the get method we just created to see. So let's do list dot contains. Does it contain the number 5? It does. Does it contain number 56? Does not. So that's pretty much it for our linked list. We pretty much defined a full linked list with a whole bunch of methods. If this helped in any way, or just you enjoyed watching, just leave a like and subscribe. This is like my first coding tutorial with the camera, so hello. Yeah, it was fun.